Okay, so the thing that marks our species out as different from the ones we share our planet with is, I think, the way that we're willing and able to try and answer some pretty difficult questions about who we are and where we're from. And if you look through time and you look around the world, you'll find different groups of people have taken their understanding of the world and added a little bit of imagination and told each other stories to try and explain these things. Now, over the last couple of hundred years, science and technology have given us more answers, more detailed answers than we've ever had. So the problem isn't one of ignorance anymore. The problem now is one of scale. How do we wrap our heads around this? What do these numbers mean? The great Carl Sagan tried to do it by taking the idea of the 13.8 billion years the universe has been in existence and scaling it to a calendar year. We haven't got a calendar year, but I do have a few of these. So what we're going to do is we're going to take the idea of 60 seconds and the idea of scaling a large amount of time to a small amount of time, and we're going to tell it, we're going to use it to try and tell these three stories. Man, Earth, the universe. Bang, there we go, there's the Big Bang. Okay, now on this scale here, each of these seconds ticking away is worth about 230 million years. Within 2 of these seconds, the universe has cooled enough for the first stars to form, about a second after they start grouping together into galaxies. You may know that song, We Are Stardust. It is literally true. Everything around you, every person around you, everything you're touching is made up of atoms. Those atoms were formed either in the Big Bang or by these stars. You can make everything up to iron inside a star. For the rest, you need supernova. Those supernova take that and they scatter it around the universe. And coming up to around the 40-second mark on here, in one small corner of one small galaxy somewhere, a new star and a new planetary system was formed. It was our star and our planetary system. And very quickly on Earth, life started, life took hold. Complex life evolved shortly afterwards, spewing out this toxic gas, which was oxygen, led to the first mass extinction event, ironically. But in the world that came after that, we evolved far more complexity. We evolved sex, for example. And on this scale right here, modern man will have existed for 0.001 seconds. Now, I don't want to tell for my second story the whole of life on Earth. Let's just take these last 3 seconds. Earth after the Cambrian explosion. Let's scale that to 60 seconds and see what stories we can tell if we do that. Here we go. So now 1 second, so only 9 million years. That's not very much, is it? So the world is now full of these little things, trilobites. You may have seen them in museums. The world looked like that, big supercontinent, Gondwanaland at the bottom. Because of that, we have a snowball Earth. We have our first of 5 mass extinction events. In the world that follows, we get fish, we get trees, another mass extinction event. In the world that followed, the Carboniferous. This is when the coal that was up in the South Wales hills, that was formed in those tropical forests. Here we go, Pangea we have now. We're coming up to our third and biggest mass extinction event, the Great Dying. 95% of all life on Earth disappears. But the world that follows that is the world of the dinosaurs. They emerge next. And what we find now is up here around the 45-second mark, life takes to the air. Archaeopteryx starts flying. Now we get flowering plants. We get T-Rex. Apparently had feathers, who knew? Triceratops. There goes that meteorite into the Gulf of Mexico. That's the end of the dinosaurs. Now we're into mammals. And finally, on this scale, 0.03 seconds before the end, we get the evolution of humanity. Now, the third one posed me some problems. Which stories are we going to tell? What scale can we use? We could take the divergence of humans from the other great apes. We could go about 4 million years, that's about 66,000 years per second. We could look through at Homo habilis, the guy who sorted out tools, or we could go Homo erectus, tamed fire, spread out around the world, evolved into Neanderthals in Europe, back in Africa, evolved into Homo sapiens, sorry about that photo. Or we could take the last 10,000 years, the Neolithic Revolution. We stop being hunter-gatherers, we start being farmers instead. That leads to cities, it leads to writing. We get something weird in the evolution of religion somewhere around here. We get the big cultures in Han China and in Rome. And finally, we end up here. So I can hear you asking, why would you bother? It's a good question. For me, I think one of the things is those numbers are quite abstract. Millions, billions, what does it mean? It's why timelines are so beloved of us history teachers. It helps put it into perspective. Here's another way of looking at that. And I think that perspective is really important. Actually, it's something I think we've got from lots of the talks tonight. The idea that actually we can look at things from a slightly different point of view. Maybe I titled this wrong, actually. Maybe this should be the histories of everything. Because I think if you shift your perspective slightly, if you tell a slightly different story on a different scale, you get a different story out of it. I think that's probably true, not just for all the stuff that we've covered here, not just for the history, but picking up on Phil's point earlier, maybe we need to do a little bit of that and looking at the world around us as well. So anyway, tomorrow I'll post the slides, all the stuff I didn't get to talk about, snowball earths and feathered Tyrannosaurus rexes. If you've got a question, if you want to challenge me on something, I'll be drinking something stronger than this in a second, or pick it up on Twitter. Thank you very much for your time. Thank you for listening.